Okay, so now there's some cautionary things I should warn you about before you get too excited. So let's take a look at this. So caution. Right. The actual definition from negative infinity to infinity for f of x dx is equal to, you have to split up in two integrals all the time. From negative infinity to c f of x dx plus the integral from c to infinity of f of x dx. That is the definition for that improper integral. You have to split it into two pieces. 1 and 2. So let's look at some old test questions that I had done before in the past. If I ask you something like this, true or false? True or false? What if I have the integral from negative infinity to infinity of f of x dx? Is that the same as taking the limit as b goes to infinity for, say, negative b to b? Can I just do that? It seems to work for some of the examples, but not all. Whoops, I gave away the answer. The answer is, of course, false. False. It's not true. And I'm sure you're sitting there and you're saying, well, why is that? Well, let's consider this example. Okay, let's consider this example. If I were to integrate from negative infinity to infinity for x dx, let's just see what happens with the formal definition. Okay? The formal definition says I'm going to go from negative infinity to, say, 0 of x dx plus the integral from, say, 0 to infinity x dx. I have two integrals. I have one integral here and the second integral here. Now let's look at the second integral first. So the second integral says that I'm going to integrate from 0 to infinity for x dx. Okay, just like we did from the very beginning, this is going to be our problem. So let's split this guy up. I'm going to say that's going to be equal to the limit as b goes to infinity for the integral from 0 to b of x dx. Okay. Now this is going to turn into the limit as b goes to infinity for 1/2 x squared, because that's the antiderivative of x, from 0 to b. Okay. And that's going to turn into the limit as b goes to infinity for 1/2 b squared minus 0, which is of course equal to plus infinity. Now remember what I said before, as soon as one of these guys is divergent, the whole thing is divergent. So what we see is that this is divergent. X dx is divergent. Okay. Now, here's the idea. The idea is that if you look at the graph of this, x to y, this is just the identity function. The identity function is pretty simple. It's just this little guy right there, y is equal to x. Notice if I split it at 0 and I go from 0 to infinity, the area under this curve, that is shooting up to plus infinity. Okay. This is shooting down to minus infinity in this region here, but infinity minus infinity is not defined. Okay. Now if I consider this integral, let's consider this guy. But if I consider the limit as b goes to infinity for the integral from negative b to b of x dx, that's going to be equal to the limit as b goes to infinity for 1/2 x squared from negative b to b. And that's going to be equal to the limit as b goes to infinity for, that's going to be 1/2 b squared minus, and then if I put a negative b and I square it, I get the same thing. That's going to equal to 0. So what's actually happening? The answer is that area should be defined no matter how we split it up. Whoops. Not who, but how. How it is split. So that's what's important about this definition. See, this definition says if you split it at C, any C value, it should work and it should be a finite value. Here, notice what happens. We're actually ignoring the tail end. We're ignoring the parts to infinity. We're just looking at negative b to b. This is a specific cut. See, this is a general cut of how we slice the space, and this is a very specific cut. Now, you'll notice, you may say, well, what about that last example that we just did? The last slide here, where this one worked out. See, notice, no matter how I would have split it up, I would have gotten two values that were exactly opposite, and they would cancel. With this example, only this specific cut would work. I mean, try to integrate this from say negative infinity to 55, and then 55 to infinity. Right? You're going to get a different. You're still going to get it's divergent. Any cut with C will work.